In this video, we're going to be writing quadratic equations from graphs. In particular, we'll be writing equations in standard form, y equals ax squared plus bx plus c. Now we're going to start by reviewing our parent graphs because in part one of this lesson, we are going to be looking at graphs that have very common a values like 1, 2, 3, 1/2. And if we know what the parent graphs look like with those a's like 1, 2, and 3, then we can save ourselves some work. So here's the parent graph of y equals x squared. Now we understand there's a 1 in front of that x squared, so a equals 1. Now notice from the vertex, when we make the first move, we go over 1 and up 1 to get to the next good point. So any parabola that has the same characteristic of going over 1 and up 1 or down 1 from the vertex will have an a value of 1 or negative 1. So let's just put plus or minus 1 here. Now here we have another family of graphs related to y equals 2x squared. Notice the first move for this one. The vertex is here and we go over 1, up 2. And notice that works in the other direction too. Any parabola with this characteristic will have an a value of positive or negative 2. If a is negative, the parabola is upside down. And notice in this family related to y equals 3x squared, if we go over 1, we go up 3. So any parabola with this characteristic will have an a value of positive or negative 3, depending on if it's right side up or upside down. It even works when we go to a equals 4, over 1 up 4. So any parabola in this family with that same characteristic will have an a value of positive 4 or negative 4 if it's upside down. Even works with fractions here. Here the first move is over 1 up a half. Now that's a little hard to tell for sure on graphs. So notice here that we have a better way of checking to see if we're in this family. If we go over 2, we go up 2. So anytime we have a parabola with this characteristic, we know that a is positive or negative 1/2, depending on if it's upside down or right side up. So in general, if we go over 1 from the vertex, then we go up or down a. Before we dive into writing equations, let's go ahead and review vertex form, intercept form, and standard form. In vertex form, y equals a times x minus h squared plus k, we have a vertex at the point hk. Now notice that it's x minus h, so this value here is always going to be the opposite of the x value there. And then the a will control the steepness. It's the same a as in our standard form equation. Now intercept form, the p and q, those tell us the two x-intercepts. And once again, the a tells us something about the steepness. And standard form. Now the best clue we can get from the standard form equation is the x-coordinate of the vertex. And to figure that out, we have a little formula. X equals negative b over 2a. Now that will tell us the x-coordinate of the vertex, and that's a really helpful number to know. Our job here on this first example is to write an equation for this parabola, in standard form. So that'll be y equals ax squared plus bx plus c. Let's take a look at our clues. We have a vertex at -2, 5. Now from that vertex, we notice we're going over 1 and down 1. Well, that tells us that our a value in our quadratic equation has to be -1, because it matches that family of parabolas. So we'll start writing our equation. Now in this case, since we know the vertex, we're going to use, or start with, the vertex form of the equation. Now this isn't the form that the directions ask for, it asks for standard form. So once we fill in a, h, and k, we won't be done quite yet. All right, we'd already determined that a is -1. The x-coordinate of the vertex is -2. So we switch that around to x plus 2, because in our recipe here it says x minus h, and x minus -2 is x plus 2, and plus k, or the y value of the vertex. All right, before we multiply or add, we do our exponents. So let's go ahead and work out x plus 2 squared. So I'm working out x plus 2 times x plus 2. So we have x squared plus 4x, because 2x plus 2x is 4x, plus 4. Right, I'm going to rewrite this equation just with the x plus 2 squared expanded. So x squared plus 4x plus 4. And don't forget about the plus 5 we still have. Right, what we're doing right now is trying to get this equation in standard form, y equals ax squared plus bx plus c. So the next thing we need to do here is distribute the -1. Don't forget about your plus 5. And finally, we have some like terms we need to combine. So here's an equation for a parabola written in standard form. Now, it's always a good idea to make sure this equation actually works for your graph. And let's go ahead and pick the easiest possible point we could choose to check our equation. And if we have an obvious y-intercept on our graph, which we do in this case, that's usually the easiest point. So let's go ahead and check and see if the point 0, 1 works in our equation. So we're checking to see if the point 0, 1 works in this equation. Let's see, y is 1, x is 0. Replace the other x with 0 also. And let's just do a quick look here. So 0 squared is 0. So 0 minus 4 times 0, which is another 0. So 0 minus 0 plus 1 does equal 1. So that point does work. So that's a pretty good indication that our equation works. Here we have another parabola. And once again, we can clearly see where the vertex is. And from that vertex, when we go over 1, it looks like we go down a half, but it's a little hard to tell because it's not right on a grid mark there. So let's go over 2 and down 2. So sure enough, that's a good indication that a equals -1/2. When looking at the parent graphs, we saw that when we went over 2, up 2, we got an a value of 1/2. Negative because it's upside down. Once again, since we know the vertex, we'll go ahead and start with the vertex form and then rewrite it in standard form. Our a is -1/2. Our h is -2, so the part inside parentheses becomes x plus 2, and k is -1. So now we are rewriting this equation into standard form, y equals ax squared plus bx plus c. The first thing we'll need to do here is square this binomial. Now, fortunately, we already squared x plus 2 over here, so we can reuse that same work. Don't forget your minus 1. Now we need to distribute the negative 1/2 and multiply each term in here by negative 1/2. Negative 1/2 times 4x, well, that's half of 4 is 2, so it'll be negative 2. And same thing here. In combining like terms, we get y equals negative 1/2 x squared minus 2x minus 3. Again, let's double check just to make sure this equation actually works for this parabola. Let's use the point 0, negative 3. That point's going to minimize how much work we need to do because the x value is 0. So y equals negative 3. I'm just going through the equation here. Negative 1/2 times 0 squared minus 2 times 0 minus 3. Now, once again, this term is 0 and this term is 0, so we have negative 3 equals negative 3. Our equation works. Once again, we're going to be writing equations in standard form, but we're going to start with vertex form once again because we know the vertex. From the vertex, we go over 1, up 3. So A is going to equal 3. Positive 3 because it's facing upward. So we'll start by writing the vertex form equation of y equals 3 times x minus 0 squared minus 5, since k is negative 5. Well, x minus 0 squared, that's the same as x squared. So let's rewrite that, or simplify it, as 3x squared minus 5. There are not any more like terms to combine, so there's our equation. This equation is in standard form, it's just missing a term. It's missing the plus bx. Let's make sure it works, though. Once again, we'll use the y-intercept since it's readily available. And that's the same as the vertex. That's the point 0, negative 5. So let's just check it real quick. Negative 5 equals, because y is negative 5 at the vertex, 3 times 0 squared minus 5. Well, 3 times 0 squared is just 0, and negative 5 does equal negative 5. So our equation appears to work. Once again, in this graph, we can readily see the vertex. And from that vertex, we go over 1, up 1. So that tells us that the a value must equal 1. Now we have all the information we need to write an equation in vertex form. Now when we have an a value of 1, well, 1 times anything equals whatever that thing is. So let's go ahead and kind of ignore that 1 and work out x minus 3 squared. Of x minus 3 times x minus 3. When we worked out x minus 3 squared, we got x squared minus 6x plus 9. And then it was just plus 0, so we have our quadratic equation written in standard form. Let's double check and make sure it works. Now in this case, we can't see the y-intercept, so the next easiest point would be a point that has an x value of 1, and we do have that point. So let's check this equation with the point 1, 4. All right, so y equals 4 at that point. The x value equals 1 at that point. Once again, we replace the x with a 1. So we're wondering, does 4 equal 1 minus 6 plus 9? Well, 1 minus 6 equals negative 5, and negative 5 plus 9 does equal 4. So our equation appears to work. In part 2 of this video, we're going to be looking at graphs where we can't figure out a quite as easily. I hope part 1 has been helpful. This is Mr. Ela, signing off.